Children, we are going to learn properties of integers. First, let us take closure property. Closure property. See, what is closure property? When we add two integers, for example, plus 6 plus 5. When we add two integers, the answer, the sum is also an integer. Plus 6 plus 5 is equal to plus 11. So we say integers are closed under addition. Integers are closed under addition. So when we add two integers, the answer is also an integer. So integers are closed under addition. So here we are going to put a tick mark, yes. Now let us subtract two integers. Minus 5 minus plus 2. You have already learned subtraction of integers. So minus 5, copy down the first integer as it is, change minus sign into plus sign and write the opposite of plus 2, it is minus 2. So what is minus 5 plus minus 2? It is minus 7. So when we subtract two integers, the difference is also an integer. So we say integers are closed under subtraction. So integers are closed under subtraction. Now let us check multiplication. Let us multiply two integers and see whether the product is also an integer. Minus 2 into plus 3. These are the two integers. Minus into plus is equal to minus. 2 into 3 is 6. So when we multiply two integers, the product is also an integer. So we say integers are closed under multiplication. So we are learning closure property. Integers are closed under addition. Integers are closed under subtraction. Integers are closed under multiplication. Now let us check whether the integers are closed under division or not. Plus 8 divided by minus 2. Plus divided by minus is equal to minus. 8 divided by 2 is 4. So when we divide two integers, here the answer minus 4 is also an integer. Now let us check some more questions, one or two more questions. 3 plus 3 divided by plus 5. Both are integers. Plus 3 is an integer, plus 5 is an integer. When you divide these two integers, your answer is 3 upon 5, which is not an integer. So, in the same way, plus 6 divided by minus 7. Plus divided by minus is minus, and it will be minus 6 upon 7. Children, when we divide two integers in the first sum, when we divide two integers, the answer is also an integer. But in the next two sums, the answer is not an integer. Therefore, we say integers are not closed under division, because sometimes the answer is an integer, sometimes the answer is not an integer. So we say integers are not closed under division. Let us recollect. We are learning closure property and we check whether integers are closed under addition. When we add two integers, the answer is also an integer. So integers are closed under addition. Integers are closed under subtraction. Integers are closed under multiplication. But integers are not closed under division. Now, let us learn commutative property. What is commutative property? Even if we change the order of the numbers, the answer should remain the same. See, this is the rule. A plus B should be equal to B plus A. 8 plus 5. What is 8 plus 5? 8 plus 5 is 13. And this side we change the order of the number. We bring second number to first place and first number to second place. We change the order of the number. What is 5 plus 8? 13. So even if we change the order of the numbers, the answer remains the same. So we say addition of integers holds commutative property. Addition of integers holds commutative property. Now let us check whether subtraction of integers holds commutative property. See, 8 minus 5, but we will check whether 5 minus 8 is also same or not. 8 minus 5 is 3. What is 5 minus 8? It is minus 3. So, on both the sides the answers are not same. These are not going to be same. So, we say subtraction of integers does not hold commutative property. Because if we change the order of the numbers, the difference is not the same. 8 minus 5 is 3, but 5 minus 8 is not 3, it is minus 3. So, subtraction of integers does not hold commutative property. Now, let us move on to multiplication of two integers. 6 into 4 and 4 into 6. What is 6 into 4? It is 24. 4 into 6 is also 24. So here, even if we change the order of the numbers, the answer, the product remains the same. 6 into 4 is equal to 4 into 6. So multiplication of integers holds commutative property. Now division of integers, let us check. 6 divided by 2 and 2 divided by 6. Let us check whether both are equal or not. 6 divided by 2 is 3, but 2 divided by 6 is like this, 2 upon 6. Or if you reduce it to the lower term, it will be 1 upon 3. Okay, so let us keep it as 2 upon 6. The answers are not same. In division of integers, if we change the order of the numbers, the answer does not remain the same. So we say division of integers does not hold commutative property. Only addition and multiplication of integers have commutative property, but subtraction and division of integers do not hold commutative property. Children, now we will learn associative property. We have already learned closure property and commutative property. Thirdly, we are learning associative property. See, associative property, in associative property, we are going to group the numbers in different ways. See, A plus B plus C. Here, we are going to put A and B in one group. But on the other side, we will put B and C in one group. And check whether the answer is going to be the same or not. 6 plus 5 plus 3. Here 6 plus 5 plus 3. The grouping is done in a different way. 6 plus 5, always solve the brackets first. 6 plus 5 is 11. So 11 plus 3 is equal to 14. This side the answer is 14. 6 plus, what is the answer of 5 and 3? 5 plus 3 is 8. So again 6 plus 8 is equal to 14. We have taken 3 integers 6, 5 and 3. On the left side of the equation, we have put 6 and 5 in one group. But on the right side of the equation, we have put 5 and 3 in one group. So even if we change the grouping of the numbers, the answer remains the same. So we say addition of integers holds associative property. Addition of integers holds associative property. Let us check whether it is true with subtraction. A minus B minus C, and here this time we put these two numbers in one group, here first and second number in another group. So always 12 minus 7 minus 3, always solve the brackets first. 7 minus 3 is 4. So 12 minus 4 is 8. This side. 12 minus 7 is 5. 5 minus 3 is 2. So both the answers are not same. They are not equal. Therefore we say subtraction of integers does not hold associative property. In subtraction, if we change the grouping of the numbers, the answer also changes. The answer does not remain the same. So we say subtraction of integers does not hold associative property. Let us move on to multiplication of integers and check whether multiplication of integers holds associative property or not. 5 into 3 into 2. 3 into 2 is in one group, and this side 5 into 3 is in one group. Second number and third number we have put in brackets. Here first number and second number we have put in brackets. Find out the answer for the brackets first. 3 2s are 6. Then 5 into 6 is equal to 30. 5 3s are 15. 15 into 2 is equal to 30. On both the sides we get the same answer. So even if we change the grouping of the numbers in multiplication of integers, the product remains the same. So we say multiplication of integers holds associative property. 20 divided by 10 divided by 5. Here 20 divided by 10 and that will be divided by 5. Let us check whether the answers are going to be the same or not. So first brackets, 10 divided by 5 is 2. 20 divided by 2 is equal to 10. Here 20 divided by 10 is 2. 2 divided by 5 is 2 upon 5. It means both the answers are not equal. Both the answers are not same. So we say division of integers does not hold associative property. Children, what is associative property? In associative property, we do the grouping of the numbers in a different way. So here we have put second number and third number in one group, and that side we put first number and second number in one group. So even if we change the grouping of the numbers, the answer should remain the same. Then only we can say the addition of integers holds associative property. Multiplication of integers holds associative property. But subtraction and division of integers do not hold associative property. Children, next we will learn distributive property. Minus 3 into minus 2 plus 8. So on the other side we are going to write it distributively. How will you write it distributively? Minus 3 into minus 2 plus minus 3 into 8. This minus 3 is common for minus 2 and plus 8. So minus 3 into minus 2 plus minus 3 into 8. So let us find out the answer on both the sides. First do brackets. Minus 2 plus 8. What will be the answer? It is plus 6. When you add two integers with different signs, find out the difference and put the sign of the greater integer. So it is plus 6. So then minus 3 into plus 6. How will you find out the product of these two numbers? Minus into plus is minus, 3 into 6 is 18. So this side the answer is minus 18. Now let us find out the answer for the other side. Minus 3 into minus 2. Minus into minus is plus, 3 into 2 is 6. Minus into plus is minus, 3 into 8 is 24. Now let us add these two numbers. One is positive and one is negative. So put the sign of the greater number, that is minus, and then find out the difference between 6 and 24, or you can say 24 and 6. The answer is 8. So on both the sides the answers are same. We say multiplication distributes over addition. Multiplication distributes over addition, because in the brackets we have taken addition. So multiplication distributes over addition. On both the sides we have got the same answer. So multiplication distributes over addition. Children, now we will see whether multiplication distributes over subtraction. Let us read the sum. Minus 8 into 7 minus 4 is equal to, that side it is written distributively. How will you write it distributively? Minus 8 is common for 7 as well as 4. So minus 8 into 7 minus 8 into 4. That's what it is written this side. Let us find out the answer. 7 minus 4 is 3, and then minus 8 into 3 is equal to minus 24. Minus into plus is minus, 8 into 3 is 24. And this side, let us do the brackets first and then come to subtraction. Minus into plus is minus, 8 into 7 is equal to 56. And next multiplication, minus into plus is minus, 8 into 4 is 32. And then we are going to do subtraction. What is the rule? Copy down the first number as it is, change minus into plus, and the opposite of minus 32 is plus 32. Now both are integers with different signs. So put the sign of the bigger integer and then find out the difference. Difference will be 24. On both the sides you have got minus 24. So we say multiplication of integers distributes over subtraction. Multiplication of integers distributes over addition also. Children, now let us learn identity property. 6 plus 0 is equal to 6. 0 plus minus 5 is equal to minus 5. From this, what do we understand? When we add 0 with any integer, whether it is positive or negative, we get the same integer. When we add 0 with any integer, we get the same integer. So we say 0 is the additive identity for integers. 0 is the additive identity for integers. Now let us take multiplication. 8 into 1 is equal to 8 and 1 into minus 9 is equal to minus 9. From this, what do you understand? When you multiply 1 with any integer, you get the same integer. Therefore, we say 1 is the multiplicative identity for integers. Children, which is the additive identity for integers? Yes, 0 is the additive identity for integers. Which is the multiplicative identity for integers? 1 is the multiplicative identity for integers.